Good morning, students. In this video, we shall discuss about the D flip-flop. The term D stands for data. So, in the previous types of flip-flops, maybe SR and JK and T flip-flop, we are facing the problem as toggling. So, toggle state ever create that is, if you are giving logic 1 to both the inputs simultaneously, I mean S is equal to 1 and R is equal to 1 means then there is a problem of toggling. To overcome this, we are moved to the JK flip-flop. There we are somewhat recovering from the toggling state, but whereas there is a thread that the circuit may get toggled. So we are moved to the T flip-flop. In T flip-flop also, we are giving a same input, I mean short circuiting both the terminals and giving as a single input as T. So we are moving to the D flip-flop. So this D flip-flop has lots of applications. So which one major application is in all the types of data memory, like example to memory elements, hard disk, like in the pen drive, all memory elements will be using D flip-flop. So hope you might remember that flip-flop is a single bit memory element. So a group of flip-flop will be forming a huge memory element like primary memory, secondary memory, cache memory, and flash disk, I mean the hard disk, group of flip-flops now. So D flip-flop means data flip-flop, which means நம்ம என்ன data கொடுக்குறோமோ அதே data தான் நமக்கு உள்ள store ஆகும். So that's why it is called as D flip-flop. So coming to the circuit diagram of the D flip-flop, so look at this one. So here we are having we are giving the same input to this, I mean same input to the both the terminals, but ஒரு not gate இங்க apply பண்றோம், which is not there in the T flip-flop. அப்ப suppose நான் D equal to 0 கொடுத்தனா 1 in NAND gate க்கு 0 வரும், இங்க complement ஆகி 1 வரும். So see to that ரெண்டுலயும் simultaneously 1ன்றது apply ஆகுது. Suppose D equal to 1 கொடுத்தோம் அப்படின்னா NAND gate number 1 க்கு logic 1 வரும், complement ஆச்சுன்னா NAND gate number 2 க்கு logic 0 வரும். So complementary values வரதால there is no threat of occurrence of this toggling problem. So for that reason we can tell D flip-flop is the most advantageous method. And designing point of view, simplicity process. So for that reason, most of the application and the designing process D flip-flop. Let me check the working of the D flip-flop. I'm giving D equal to 0 and present state equal to 0. So D equal to 0 and present state is also 0. So present state 0 almost one. Most important thing is the feedback that we use. So if you are giving 0 here means this will be made as, I mean, in the NOT gate complementary here will be having 1. Clock pulse by default 1, rising it's 1, 1. So what is 0.1? It's 0. Complementary it will be made as 1. What is 1.1? It's 1. Complementary it will be made as 0. In the present state 0 so 0 will be given here. So 0.0 is 0. Complementary is 1. So 1 will be given here. 1.1 is 1. So complementary is 0. So present state 0, next state is 0. So Q in plus 1 is 0. Next set of input will perform D0, Qn 1. D0 and my present state is equal to 1. 0 will be given to the first NAND gate. So this is the first NAND gate. And the complementary action 1 will be given to the second NAND gate. This is the second NAND gate. Clock pulse by default 1. Rising it's 1, 1. So 0.1 is 1. Sorry. 0.1 is 0. Complementary action 1. 1.1 is 1. Complementary action 0. Present state 1 is human. So 1 will be given here. 1.0 is 0. Complementary action 1. This 1 will be given here. 1.1 is 1. Complementary is 0. So here we will be getting 0. Coming to the next set of input, it is 1, 0. D equal to 1 and 1 equal to, sorry, present state equal to 0. In this case, 1 will be given to the NAND gate number 1 and the complementary is 0 tomorrow. Clock pulse by default will be set as 1. What is 1.1? It's 1. Complementary is 0. And 0.1 is 0. Complementary is 1. Present state 0 is 0. So 0.1 is 0, complementary is 1. So here 0.1 is 0, complementary is 1. So next state is equal to 1. Coming to the final set of input, D1 and the present state is also D1 and present state is also 1. So 1 will be given here and the complementary is here it will be 0. And then here clock pulse default of 1. So this will be 0. Because not get together. So 1.1 is 1, complementary is 0, and 0.1 is 0, complementary is 1. Present state 1 is 0, so 1.1 is 1, complementary is 0 over here. This 0 will be given here. 0.0 is 0, complementary is 1. So next state is 1. So one thing we shall be able to observe here is நான் D வேல்யூ என்னதான் கொடுக்கணும், D0 இருந்தா என்ன சொல்லிருக்கேன், D வேல்யூ என்ன வருமோ அதே தான் வந்து எனக்கு டேட்டா உள்ள ரெஜிஸ்டர்லையும் ஸ்டோர் ஆகும் சொல்லுங்க. ஐ மீன் உள்ள ஃபிளிப் ஃப்ளாப்லையும் ஸ்டோர் ஆகும் சொல்லுங்க. ஸோ D என்ன இன்புட் கொடுக்குறோமோ அதே தான் நெக்ஸ்ட் ஸ்டேட்லையும் வரும். லுக் அட் திஸ் ஒன். D0 na UN plus 1 is 0. D0 means my next state is also 0. D1 means my next state is also 1. D1 means my next state is also 1. So இதான் சொல்றோம், D வேல்யூ என்னவோ அதே தான் நெக்ஸ்ட் ஸ்டேட்டுக்கும் வரும்னு சொல்லுங்க. Coming to the characteristic equation. So here we are having Qn plus 1 is the output, whereas input are D and Qn. So only two inputs, so two variable came about D and then Qn. What is the value here? 0 on the next state is 0. 0 1 to next state is 0. 1 0 to next state is 1. D 1 1 to next state is 1. So here two grouping pannalam. What will be the value here? So we can write my next state, I mean my characteristic equation Qn plus 1, which is equal to, in the table in the Boolean expression of D, Qn cancel. So that means my next state is directly equal to D la enna value irukko adhe dhaan varum sollirukken. So characteristic equation for D flip flop is Qn plus 1 is equal to D. That's all. So now based on this one, we have to plot the based on the characteristic table, we have to plot the excitation table. So in the previous videos itself, I have mentioned that what is the excitation table is. எனக்கு ஒரு குறிப்பிட்ட அவுட்புட் வேணும் அப்படின்னா அப்போ நான் என்ன இன்புட் கொடுக்குறேன், இன்புட் இன் தி சென்ஸ் எக்ஸைட்டேஷன், அதான் செக் பண்ண போறோம். So look at this one. In this one, this particular table is the characteristic table which we have just now we had plot now. This is the characteristic table, and then from this we are going to derive the excitation table. So Qn plus 1. So Qn present state next is 0 or now what should be the input? 0. So that is the 0. Present 0 next to 1. Present 0 next, present 0 next to 1 means my D value should be 1. So here it is 1. Present 1 next is 0. Present value is 1, next is 0. My D value should be 0. So here it is mentioned as 0. Present 1 and next value is 1 means my D value should be 1. So this is mentioned as 1. So in this video we shall discuss, we had discussed about the D flip flop, its characteristic equation and the excitation table. Hope you all understood. What are the types of flip flops, SR, JK, D and T flip flop. In the next video we shall discuss about how to convert one flip flop to the other. Thank you.